Thanks for choosing this talk. My name is Márton Braun. I'm a developer advocate at JetBrains, and this is going to be composing an API the right way. So in this talk, we'll explore some guidelines coming straight from Google on how to better design APIs for Jetpack Compose. It's no secret that I'm passionate about API design. I've given a couple talks and wrote some things on this topic before. And I'm passionate about API design because I really believe that everyone is an API designer if you're writing code, regardless of which part of this scale you're on. So whether you're building some really core framework or library that a lot of other people are going to depend on and call into the APIs, or you're just writing application level code, you are still designing APIs, you're creating functions, other people are going to call into that, like your teammates if no one else, or if you're a solo developer, you're going to be using those APIs later. So we are all designing APIs whenever we're writing code. And how important it is to have well-designed APIs depends on what kind of code you're writing. So if you're writing something very foundational that a lot of others are building on, it's really important to design nice APIs, whereas on the other end of the scale, if you're more in the application realm of things, then you can be a bit more loose about the rules, and that will apply to everything that I'll present today as a rule. So what we're covering here is these two guideline docs from Google. These are about 13,000 words in total. They're two lengthy technical documents. They are extremely valuable for designing for Compose. And they're also about 2 hours to read, estimated by some random online tools based on their length. So we're going to try to condense some of the highlights of that into this 40-minute talk. The idea behind these is that they're supposed to help you with writing idiomatic Compose code. The idea is to have a common set of expectations on how we design APIs for Jetpack Compose, on how components that we build in Compose will behave. And if we have those common expectations and ideas about Compose components, then if we have experience with some components, like foundation and material things, we can reuse that experience when we start using some new library from Compose that also ships its own components. So both of these guidelines are for Jetpack Compose specifically, because these are, of course, from Google. But I do have to highlight here that everything you learn about Jetpack Compose API design will automatically also apply to Compose Multiplatform, which is a project by JetBrains, which allows you to take the same Compose APIs and compile them and use them on different platforms. So not just for Android, but also on iOS, desktop, and the web. The current state of this is that on iOS, it's in alpha. On Android, it's stable. Of course, it's just Jetpack Compose. It's also stable on desktop already, so you can build desktop apps, Windows, macOS, Linux apps using Compose Multiplatform. If you use JetBrains Toolbox, that's actually a Compose Multiplatform app for desktop. And there's also web support, which is super experimental at the moment, but it's really fun to play with. So a quick overview of the topics we're going to touch on. We're going to start with some simpler things with naming. Then we're going to go into looking at how we create parameters in Compose and some specific important types of parameters. And finally, we're going to take a look at state handling things. Starting with naming then. So Kotlin's default convention, naming convention for constant values looks like this. It's this shouting case that you know and love from Java, maybe. But Compose doesn't use this. Instead, this is the naming convention that Compose chooses to use. So it's the Pascal case or Apple camel case naming convention, where we actually go against the recommendations of how to name Kotlin properties, and we start it with an uppercase letter. And Compose doesn't just do this for actual constant values, but also for things that are reference types, so just regular top-level properties, which are semantically, functionally, they are also constant values, as well as for objects, whether they're top-level or maybe nested in some sealed hierarchy, as well as enum values, which are also practically constant values. So the idea behind this consistent naming convention is that you shouldn't care about the implementation details of that constant. The important part is its behavior, which is that it should be a constant value over time, like a stable value, always the same reference. And then the implementation in detail can be whatever. Let's move on to functions, which is a bit more interesting. Does anyone care to shout what the naming convention is for functions in Compose? Does anyone know this? Brilliant. It does depend. That was a planted answer. So the reason why it depends is that we have two kinds of composable functions. Composable functions can either emit content or they can return a value, but never the twain shall meet. There should be no overlap between these things. So each composable function should fit into one of the categories. On the emit content side, we have the composable functions you might think of first. So things like button and column, all of these things that create UI. And all of these things are some kind of entity. So as a result of these functions being called in your composition, nodes will be emitted into the composition, and a thing will exist. So it's really important that these are named as nouns. So button, column, all of these are nouns. And this doesn't necessarily have to be just UI. So for example, something like a launched effect is also a thing that will exist as a result of that function being called. So we also use the same uppercase naming convention. On the other side of things, we have the composable functions that return a value. So these are named like any regular function in Kotlin. They have lowercase names, something like a string resource or any of the remember type functions, for example. And the purpose of all of these is to produce a value. And the reason why they are composable is because they depend on something in Compose. So whether that's some composition local values, or they just make reads to compose state and produce values dynamically based on that. But their primary purpose is to produce a value. And elaborating on the second category, Kotlin has this nice convention where if you have a factory function, like a virtual constructor, you can use the same name for the function itself as the type that you're producing. But in this case, with composable functions, you should not do this. So you should not use this special convention that Kotlin's naming guidelines have. But instead, you should always stick to lowercase naming, because uppercase names are for entities, for things that produce things into the composition. You should especially not use the uppercase naming convention if your composable function does anything exciting. So for example, if it also automatically remembers the value that it's going to produce, then you should use the remember prefix for the function name. And again, it should be a lowercase name. OK, at this point, I want to define a term. I want to define component. The guidelines define about 3 different terms, which all kind of contribute to the same idea. So I've just merged those things, and I'm going to call this a component for the sake of the talk. So components in this discussion are going to be a composable function that returns unit and emits exactly one compose UI tree node. Returns unit, emits a compose UI node. And we're going to take a look at all of this in detail, starting with why components should emit exactly one UI tree node. If we take a look at a bit of compose code, we are always building trees by making calls to composable functions. For example, this snippet here would result in building this sort of tree in Compose. So we have the root of the tree, which is the column, which has 3 children, the text in the row, and then we have 2 buttons and 1 text in each of them. So we're always assembling a tree like this. And one of the really, really awesome things about Compose is that it's just Kotlin code. So we can look at any arbitrary part of our Compose code, and we can decide that we want to grab that and extract it to its own component. So for example, we could take those 2 pieces of text that we had there. We could move that into a new component. And in the place where they used to be, we can just call into the function that we have just created. And this would work fine. In this case, our code would do the exact same thing as before. This is a valid refactoring move. But the problem is that by doing this, we've created a really strange component here. So this title function relies on the fact that it's being called inside of a column. It doesn't have a single root, but it actually emits 2 different nodes into the composition. And this only works if it happens inside of a column. So it's not like a healthy, like self-sufficient component. It has this implicit dependency that's not really captured anywhere. And we can't freely use it in any place in our Compose code. And this produces a very classic problem, which looks like this. So if you call this not inside a column, but somewhere else, maybe inside something that's a box layout or something like that, you can really easily end up with layout problems because this composable emits 2 nodes instead of just 1. So the solution here is to create a nice self-sufficient component with a single root node. In this case, we could wrap our 2 texts in a column. And that would make sure that this is a composable that can exist on its own. It's a nicely designed component. And wherever we call it, we'll have some proper layout for it. I also hope you got the subliminal message on these slides. All right, getting back to our definition, the other thing I want to look at here is why composable functions should return units. So we've discussed earlier that composable functions, well, these components specifically. So we've discussed that composable function can either produce things into the composition or return values. And so this one shouldn't return values. These should return unit. So the reasoning here is that you might be tempted to do something like this, coming from less declarative code. So, for example, an input field composable, which returns a state, which is an object that can then be used, for example, in this button here, to clear the input of the input field when the button is clicked. So this can be tempting to do in Compose, and I'm pretty sure that you can do it, and it will work, but it introduces problems. The first problem is that there is a split responsibility for this state now, because the state has been created by the input field, and it can probably mutate that state itself internally, but it also returns the state to us to mutate it. So it's a stateful composable. It has its internal state. It's managing it, but we also get that same state object. So it's like 2 different places in the code where we're managing the same state, and these are like independent of each other, which is not ideal. The other problem is a lot simpler to see. It's just an ordering problem in code. For this input state to exist, we have to call this input field function now. So if we just want to move our UI around a bit, that no longer works because the state doesn't exist until we call the input field function, which is just really annoying in Compose because you want to be able to freely move around these components. So the solution for this is to not have stateful components like this, and especially not components that return values that are like handles to state that you can manage. But instead, components should be driven by external state. We should pass in the state as a parameter to the component, for example, like this. This way, we have clear ownership. We can create it. We can create the state object externally to the component. We can create it in any point of the composition. And then, of course, we also don't have any ordering problems anymore because we just created that state anywhere, and we can reference it anywhere after that point in the code. So this is the general idea of driving Compose components. If you've ever seen a Compose talk, you've seen this slide. So these components, these functions are supposed to take data in, and they are supposed to produce UI based on that data. And this should all be a pure thing that ideally doesn't depend on anything else. And the primary way that Compose functions will take in data is through parameters. So we're going to talk about a bunch of things related to parameters next. And the first thing I want to do here is actually a tangent where I want to talk about not parameters, but composition locals, which are the alternative way that you can pass data into your Compose components. So I'm not going to explain all of the composition local APIs and how it works here. You can learn more about that on the link on the slide. All the links are also going to be at the end, so you don't have to save them individually. But the short version is that composition locals allow you to expose data somewhere at some point in your UI tree, and then anything else nested below that point in the hierarchy we'll be able to access that data. So if we provide some data using a composition local, then any nodes in that subtree can like reach out and grab that piece of data through the composition local APIs. And this can get quite complex. You can have very implicit dependencies like this, where that component that's down there in the root node, in the leaf node down there, can no longer be used in other places in your composition because it depends on that composition local value being available. And so the guidelines essentially say this. It's fine to use composition locals for styling, which is like a really global concern. You want to be able to switch styling like at a very high level and have it apply to a very large hierarchy. But you should really not use them to pass data around. You should prefer using explicit parameters over the implicit composition local APIs, even if it means that you have to do a lot of passing down parameters. Compose really likes it when you're explicit about the dependencies of your components. Another thing that Compose really loves using is default arguments, which are a great Kotlin feature. And what this enables in Compose is components with a lot of customization, like the built-in text composable, for example, which can also be called without all the customization. So in the case of text, for example, you can call the text component passing in just a single string. But then if you need further customization, you have all of these other parameters that you can start providing. We can also see a nice example of using a composition local here. So this is also like an approved convention that you should read composition local values as the default values for parameters. Because this way, the component can pick up those values from the composition local by default, but the callers can always choose to override them by providing their own value for the parameter. Something you should not be doing, which you might be tempted to do, is using null values in your default arguments to mark that a value has not been provided by the caller. So, for example, you might think that you can just have a nullable style here. You'll use a null value by default, and then within your implementation, you'll resolve that to some kind of default value instead, like the composition local, if actual value hasn't been provided. But you should try to stay away from this. You should not use null as a marker, which just means use a default instead. You should just use the default value itself, as we've seen on the previous slide. But you can still use null in cases where it has the original meaning of null, where it means that it's an absence of value. For example, if we take a look at the button composable, that uses null as the default border. And in this case, null really means that the button should just have no border. So in this case, it has the appropriate meaning, and this is a good use for a null value in default arguments. Another thing that button is a great example of is grouping all of your default values into an object. So this is also a convention in Compose, where you can create a default object if you have a lot of different default values that your component relies on. The naming convention is like component name defaults, as you can see here. And that way, all of these values can be easily accessed. You can find them all in a single place. You can see that button defaults has a bunch of sizing values as well as some helper functions to create some button-related type, like the button colors and button elevation types. And if you make these default objects and these default values that you use public, then they are also reusable by your callers. So here's an example where we're calling button, and in some cases, we have some custom colors to use. But conditionally, we also want to fall back on the defaults. And again, we don't need to use like null here for signaling or anything like that, because the default values have been provided in this nice object and they're all public. We can just reach into that and use the default values in different conditions. Another use case would be if we want to take the default values and only customize a small bit of it, we could grab one of these default values and copy it if it's a data class, which is also super convenient. And for this to work, all you really have to keep in mind is that you shouldn't restrict the visibility of your default values. In general, you should prefer that these stay public, even though like minimizing APIs is a really nice idea. For default values, it's great if you expose them and share them with the callers of your components. Next up, I want to talk about modifiers, which are one of the great things about APIs in Compose. And modifiers are the answer to the problem where if we wanted to provide a bunch of different customization options for all of our components for padding and sizing and background color and clipping and shape and all of these things, we would have this exploding parameter list that we would have to include for each one of our components. Whereas with modifiers, we can accept just a single modifier that we then apply correctly to our component. And thanks to this chaining API, we can provide all of these common customization and decoration things as just a single parameter. Because we have this modifier API, this also means that we shouldn't add extra parameters that do the same thing. So for example, we shouldn't have a padding parameter on our component because that's already handled by modifier anyway. Something you might be wondering is whether or not you should provide a modifier parameter in your components. And what you have to realize about this question is that if you don't provide a modifier, all you're really doing is making customization more difficult, but you're not preventing it. So for example, if we don't have a modifier parameter here, we can always call this original function, wrap it in something like a box, and then apply modifiers to that wrapping layout. And we've pretty much achieved the same thing. But if we were to have provided the modifier in the first place, then we would have been able to do this with less nesting and with a more convenient API. So even if you don't provide a modifier, customization of your component will still be possible. It will just be inconvenient and very slightly inefficient. So in general, you should accept a modifier parameter in your components. By convention, that parameter should be named modifier, as you've already seen here. It should be the first optional parameter of the parameter list. It's important that you apply it to the root node, and it should have a default value of modifier. We're going to take a look at all of these things in detail. The first two we've basically already covered, and they're fairly self-explanatory. We're going to get back to parameter ordering in just a moment. So I want to look at this thing first, which is why the modifier should be applied to the root node. So here's a correct application of the modifier parameter. We have the parameter on our component. Inside our component, we do a bunch of different things. But if you think about it, looking at this component from the outside, this component is essentially a column. As a caller, if you call into this component will visually look like a column to you. It will behave like a column. So if you want to customize this component, it makes sense that those customizations should apply to the column, which is the root of this composable. An incorrect way of applying a modifier would be something like this, where instead of applying it to the root, you would apply it to something nested further down inside the implementation of the component. And the problem with this is that any customizations would only be applied to a part of your component. So again, looking at this component from the outside, it is essentially a column. But if you were to set the background color of that column, for example, by passing in a modifier, it would no longer apply to the entire column, just a part of the composable, which is unexpected. So you should make sure that you always apply that parameter to the root of your component. And we've, of course, already discussed that you should have just a single root in each of your components, a single root node. Something interesting to consider is that you might have to use that modifier parameter in multiple places within your component. For example, this snippet here has a component which, based on some Boolean value, either configures itself to be a column or a row. And whatever composable call ends up being the root node of your component, either the column or the row in different cases, the modifier should be applied to that root node. But it's important that overall it should only be applied once in any of these conditional cases. OK, and then the last thing we had here was that we should have a default value of modifier. In case you haven't looked into this yet, let's take a look at how this works and why this is useful. So when we use the modifier default value, that's actually the companion object of the modifier type, which itself implements the modifier interface. And this companion object serves as an empty implementation of a modifier. So having this as the default value is great because it's an empty implementation. It doesn't do anything. So we can safely apply it to the root node of our component by default. But if someone does pass in an actual value, then we'll apply those customizations to our component instead. Something you're also allowed to do is you can take that modifier parameter and you can append additional things to it if you want inside your component. So for example, we can take that modifier parameter and change some other modifier functions onto it. But you should make sure that you only do chaining starting with the original modifier. So you should not build up new modifiers and then chain in the parameter you took somewhere along the way. You should always start that chain with the original modifier that you received as a parameter. And this is important because modifier ordering matters a lot. And while we're not going to dive into that, you can check out the documentation for Compose modifiers, which explains why ordering matters and how that works exactly. Other than modifiers, my other favorite type of parameters in Compose are slot APIs, which are this idea that in Compose we can really easily pass UI around as parameters, as we have Kotlin function types that can be parameters, and we can make those function types composable. If you've ever had to do this with the view system, provides like parameterized UI into other view-based components, I think that's an extremely difficult task. Whereas in Compose, it's one of the simplest, like basic things that you can do, which is really, really convenient. If we take an example like one of these like basic button implementations, we can see how we can use a slot API. We can pass in one of these composable functions as a parameter. And then on the call side, we can provide some composable code as a function, in this case a lambda, which is passed into the button. So you should be familiar with this. Something exciting that you can do here is instead of just taking a regular function, like a regular composable function like this, you can add some further customization by already placing the caller inside a scope. So for example, in the case of a button, as we're passing in multiple things, like we want an icon and a piece of text on that button to be displayed, we might know that there is a common layout that callers tend to use to arrange things within our component. So in cases like that, we can already provide that layout as part of the implementation of our component. So this button automatically places whatever is passed inside a row in its implementation. And to express this, we have this row scope receiver added to the function that we take as a parameter. And this way, we see even on the call side that whatever content we're passing in is going to be arranged inside a row. This is also great because it gives us access to all the things that are available only when you're inside of a row. So for example, there's the weight modifier, which you can only use when you're inside of a row because it's specific to that layout. And in this case, that modifier would be available thanks to us being put into this row scope. Something you might be wondering at this point is, haven't we just created a component here which emits 2 nodes instead of a single one? That was a rule earlier, right? Well, not really. The function that we have here, this lambda that we've created, is a composable function, but it's not a component. It's not a standalone compose function that could be called from just any arbitrary place. We've created it for this specific use. And because we have this row scope as a receiver, we actually know that whatever we emit here will be arranged in a row automatically. So we don't have to worry about how these multiple nodes are going to be arranged. We know for sure that they're only going to be put inside of a row. An interesting consideration that you can make around using slot APIs is the lifecycle of the slot that is provided. So here again, I have a component which, depending on some parameter, arranges itself either into a row or into a column. And in both of those layouts, it uses the slot parameter, that composable function that it took as a parameter. And as time goes on, from the top to the bottom of the slide, this preference item, the host component, starts existing at some point, and it is part of the composition for a while. But the nested content, which is created at the same time as when the preference item is created, will actually only exist until that checked value changes. So every time that checked changes between true and false, we go from one of the branches of preference item into the other, which means that the existing content that we've created will be disposed, and the content function will be called again to produce the UI again, so that it can be placed into either a row or a column based on a condition. And this is a problem because we're doing too much work. We're calling the content function too many times. We shouldn't dispose its contents every time that we need to change some state. And Compose offers a very specific API for exactly this purpose, which is called movable content off. So you can take your initial content function, you can wrap it in movable content off, which gives you another composable function, which you can then remember inside your component. And whenever you call the movable content function, it will either invoke the original content function to produce the nodes, that, like the UI that it wants to emit, Or if that has already been done, it will grab the existing nodes and just place it into the new location within the composition where they're supposed to be. So it literally moves the content from one part of the composition to the other as we're switching between different layouts. There's a great article about exploring this, as well as movable content with receiver off, where you can learn more about how these work and what else you can do with them. So to wrap up the parameters part of the talk, I want to talk about ordering parameters next, which is also something that's a really common topic in Compose API design. And these are the general rules for this. So required parameters should come first. Then we should have optional parameters, with the first one of them being a modifier. And then if we have a primary slot that we're taking as a parameter, then that should be called content, and it should be placed on the bottom of the parameter list. To learn a bit more about this ordering, I've taken this random function from an open source project, and we're going to explore how we can fix it up a bit to adhere to these principles. So first things first, required parameters should come first. The idea behind this is that the composable should be callable by just providing the required parameters with none of the optional parameters. So in this case, we need a Boolean value and 2 functions to be provided, which would look like this. But because we don't have the right ordering for parameters, we can't make this call because these parameters are positional, and the modifier is actually the first parameter of the function. So to fix that, we can move the required parameters to the top, and this way, with the minimum set of required parameters, we are able to call our function. Of course, you can always work around this by using name parameters, and especially with parameters like this, like Booleans and functions, which might not be self-explanatory, it is a good idea to provide name parameters, but you should still put required parameters to the front of the parameter list so that named parameters are not required for every single call of your component. Then we should have optional parameters, and the first one should be modifier. This is actually already true for our function, so we don't need to change anything. The idea behind modifier as the first optional parameter is that whenever you call a component and you've provided the required parameters, if we all follow the same guideline of putting modifier as the first optional parameter, then pretty much without thinking, if we need to customize this component call, we can just throw in a new modifier on the parameter list. And if we follow the convention, then that modifier will actually be the next parameter. And again, we don't have to do name parameters every time in order to pass that in. So that brings us to the final rule, which is that if we have like a primary slot that we take as a parameter, it should be at the end of the parameter list. This, of course, facilitates the nice trailing lambda syntax in Kotlin, where you can place that lambda outside of the parameter list and have this like visual nesting of things. And this is also already positioned correctly in the parameter list, but there is a convention to name it content, so we can fix that up as the last change that we make to this component. All right, with that, I want to move on to the last section that we're going to look into, which is going to be about handling and passing in state to components. And I will start with the literal state type from Compose and ask the question of whether it's a good idea to pass in a mutable state into a component for it to work with. And the fast answer to this is no, you should not do this. This, again, is a problem of shared ownership of state. So if we pass in something as a mutable state to a component, then that component will be able to mutate that state arbitrarily without us being able to control it from the call side. So this is a problem because, again, we modify that same state. We own that state in multiple places, and we don't have proper control over it. It's much better if we create a stateless component like this, which is only controlled externally. So we can pass in the state as a plain value. And then we can provide a callback for the component where it can indicate that it wishes to change the state, but then we get to handle those requests to change the state on the call site. And if we need some validation on there or we need some customization, we can now easily do that as the consumer of this component. Something interesting to ask here is, OK, so mutable state is bad because it allows the component to mutate the values that it received. But what about passing in regular state as a parameter? This is still something you should avoid. This isn't dangerous in the sense that we don't have the ownership problem. but it just makes the component really specific and really difficult to use. So for example, if we want to call this scroller component, and we already have a plain float value that we want to pass in as the offset, we are unable to do that because it requires a state specifically. So in this case, we would have to do something like create a new mutable state object just to be able to pass in a value, which will probably read again from that state inside the component. So in order to keep your components easy to call and like friendly to use, you should just use plain values for parameters most of the time. Something that you can consider other than plain values is using functions that will produce specific values. This allows a lot of flexibility on the call side. So for example, we could make all of these calls to this component now. We could provide a constant value or a plain value that we have from somewhere. We could read state object. We could read some other object that's backed by composable state. Like we could produce our value however we want. And all of these would now work. So for flexibility, you might want to provide a parameter which can produce a piece of state. And this can also be useful for deferring reads to state. So if we don't read the state before calling the component, but we pass in a function that's able to read the state, we can do all kinds of nice optimization with that, which you can learn more about by reading this article. Again, the links are going to be on the last slide as well. All right, finally, I want to talk about state holders here in the topic of state. So as you're building your components and you are using this nice pattern of taking plain values and taking callbacks so that the component can indicate that it wishes to change some of these states, you might start having a lot of these parameters, and you might want to simplify this because currently, for anyone calling this composable, they would have to create 2 pieces of state. They would have to pass in 4 parameters. So it's just a lot of work to use this composable component. So in order to work around that, we could extract all of these different pieces of state that the component works with into a state type like this. This now contains the 2 different properties that we really want to work with inside our component. And then we can just take one of these types as a single parameter. You can see that there's a naming convention at work here. The convention is to have the component name and then a state suffix for the type that we create. And these types should also be stable. I'm also not going to go into stability at this point, but you can learn more about it in the official documentation. But stability generally is the idea that whenever the values inside this state holder change, the composition should be notified. So to put it simply, these should probably be backed by mutable state in their implementation. And because we've created an interface, right now, eddy callers have to implement that themselves when they want to use our component. So a good idea is to provide an implementation for that interface. So here's a very basic implementation where we just delegate each of the properties into a mutable state. And to make the API even nicer, we can provide a factory function like this so that the implementation can remain a private detail. We can restrict the visibility of that class. And we can have this factory function which produces an implementation for the interface. And so that callers don't always have to do that, we can add this as a default value to our component to wrap things up. So if no state is passed in, our component can be called without any parameters, and it will just create a state for itself, which it remembers. So that's a lot of code for solving the problem of having to pass in 4 parameters into the component, although we did solve that problem on the call side. The call side now would be really nice because it can be called with 0 parameters. But in a lot of cases, especially if you're not building libraries, all of this will not be necessary. If you're inside just a regular application, you can just straight away create one specific implementation for your state holder. It can be as simple as this. And then if you realize later that you need multiple different implementations, there is, of course, just tooling for that you can use. OK, to wrap up, I don't expect you to remember all of these rules after having watched this talk. The idea is that these documents exist, that these ideas exist, and whenever you need to make design decisions when building your composed components, you can refer to them and see if they help pick between the different things that you came up with. And there's also actually tooling that can help you. So there's this composed rules repository, which used to be maintained by Twitter, but has been taken over since then on a fork by Nacho Lopez. And these rules can be used with either ktLint or detect, so they're static analysis rules, and they cover a lot of the guidelines. So like modifier ordering and not emitting just a single root and having a modifier parameter on all of your components. These give you warnings for all of those things. And just once more, I want to highlight that you don't have to very strictly adhere to all of these rules. If you're just building applications, you can feel free to deviate, like do whatever fits your own teams and your own coding style. But if you're building something foundational, if you're building a library for everyone else to use, then please strongly consider using these guidelines. That's a wrap for composing an API the right way. Here are all the links that you can check out if you need to look up the resources. You can also find the links and the slides on my website. And if you want to stay in touch, the best way to follow me is probably Mastodon at this point. But I'm also really, really happy to talk to you in person if you have any questions about this talk or Kotlin multiplatform or Compose multiplatform, just in general. Yeah, thank you.